Here's a tutorial on how you can use the solubility chart. This is located on the back of your periodic table. This here's the metal activity series, which we use for single displacement reactions. Here's the solubility table that we use for double displacement reactions. In a double displacement reaction, you always have two solutions, so aqueous, two ionic solutions mixing. And if there's a reaction, then when they combine, one of the products will have low solubility and will be a solid. If there is no reaction, then both products remain dissolved in solution as aqueous solutions. So let's take a look at how we read this chart. Over here you see that it says high solubility aqueous, low solubility solid, and this is referring to the cations. So you'll see all in here we have different cations. So group 1 would be any of the cations in group 1, so sodium, potassium, etc. Group 2 would be any of the ones in group 2, such as calcium or barium. So we also have cations that have very specific charges. This one here is copper 1+, not copper 2+. And then at the top we have our anions. So here's a list of some of them. This table does not include all of the possible anions, so just keep that in mind. So let's do an example. Will sodium and sulfate form a precipitate? If sodium sulfate were to be one of the products in a double displacement reaction, would it be solid or aqueous? Well, you're going to start by finding the anion. So sulfate, SO4 2-. So let's find that. That's SO3. Here it is, SO4. So now we're just concerned with this column. Now, sodium. Is that one of these 6 specific ions? No, it's not. Would sodium fit under the description of most or all group 1 compounds, including acids, and all ammonium compounds are assumed to have high solubility in water? Sodium fits under this category, so we will now move this way. It will have high solubility. It will be aqueous. So Na2SO4, if that's a product made, will be aqueous. Let's look at another example. Will copper chloride be solid or aqueous? Well, let's consider chlorine. We'll find it here. There it is, right there. So now we're just concerned with this column. This is copper 1+. I know that because chlorine always forms a 1- charge. There is 1 and 1 of these in this compound, therefore the copper has to be the 1+ ion, not the 2+ ion. And if we look in our chart, here it is here, copper 1+. It is one of these 6 specific ions. It has low solubility. So CuCl will form a precipitate, and that does mean that a reaction did occur.